Okay, another problem we have to find the x and y intercepts. So again, Mr. Larson loves x and y intercepts. And, well, he doesn't love them, but it's a prominent theme of the class. If you know how to do them, it makes it a heck of a lot easier to know the concept behind it. So again, the y-intercept, my y is just to the first power. Okay, and again, we're going to replace the x with 0. And then the x is to the third power. Now, I'm going to actually put 3 of these. Not saying I'm going to need them, but sometimes with third powers and second powers, you're going to have 3 at the most. Sometimes, though, you just have 1. So if you get them all set up, it helps a lot. Okay, now insert 0 in for your x's, and you can just roll that on your calculator. Okay, so parentheses 0 minus 4 to the third power, negative 64. That's your y-intercept. Very easy to find that. Now the x, so at the x-intercept, all the y's take a 0 value, and I go 0 equals parentheses x minus 4 to the power of 3. Now you remember solving these when you had a parentheses of an expression to a value? We're going to set up the Q table with x minus 4, but since it's to an odd power, we only need one side. So that's what means I'm only going to get one thing, okay? So 0 equals Q to the third power. Okay, well, you just do a cubed root, but the cubed root of 0 is 0, okay? Any root of 0 is 0, so you set it equal to 0. So again, it'd be 0 equals Q to the third cubed root, and then make your table. And add 4, and your x-intercept's 4. And these would not exist, okay? I at least want to keep my eye out for them, though. Okay, now right here, I want to add something to this problem. I would like to add a minus 9 behind that. Okay, so again, x int, y int. Only one y-intercept. X is 0. Now again, now we have a second power to the x, so there would be at most 2. And the y, it takes a 0 there. So we put 0 in for x, and then I solve for the y. You can just roll that into your calculator. 16, okay, if that's your y-intercept. That is where the graph will cross the y-axis. Okay, now we put 0 in for y, and then rewrite the equation just like we have been doing. Okay, now I'm going to use my q, okay, because I really can't get the x by itself, so I'm going to use 0 equals q to the second minus 9. I'm going to make my table here. Now the power's a 2, so I'm going to use both sides. So x plus 5 equals x plus 5 equals. And I need to undo the operations with my q. So 9 equals q to the second. And then I'm ready for my root. It's just a square root, and the square root of 9 is 3, okay? But it could be 3, could be negative 3, so I'm going to find both of these. So minus 5, and that's negative 2. Then minus 5, and that's negative 8. Okay, next one. Okay, so there would be only one y. There's usually only one y-intercept. So maybe he'll have you do some, but at least 0. And x-intercept, I'm going to list out 3 of them. That doesn't mean I have to find all of them. Sometimes you can't. And all the y's are 0 here. Then you put 0 in. That's easy to just roll in on your calculator. It's basically negative 6 to the third power, but I'll punch it all in. So negative 216. Remember, you don't have to graph these. Now we put 0 in for y. Again, when I have that power that belongs to an entire expression, I'm trying to solve for that variable. I usually like to bring in my q. I only need one side because now we're back to odd. So x minus 6 equals, and then replace the parentheses with q. And I'm ready for my root right away. Okay, I'm finding the cubed root of 0, which is 0. Okay. Any root of 0 is 0. You don't need to even calculate that. So it's 6. And these other two won't exist. Only one y-intercept because your y is only to the first power, x is to the second. So I'm going to look for 2 of them. Okay. And a funny thing happens when I do my x-intercepts here with the second power. So my y, I put 0 in for x. Okay. You should be able to do this in your head. What's 0 plus 2? 2. What's 2 to the second power? 4. You don't need a calculator for that. Okay. Now the y is 0, and then again replace your y with 0. So at first glance, I'm going to use my q, and it's to the second power, so it's an even. So at first I think, well, I'm going to need both sides here. But I go right to my root because there's no operations like there was on this first one where I had the minus 9. You know, I had to add, got 9, and 3 and negative 3. Here I don't have that number I have to add, so I go right to my square root. Well, square root's 0, so you're like 0 and, well, negative 0 is not even a number. That's not even possible. So you actually end up deleting that because, you know, you can't switch 0 to its opposite. So you only have 1 here. Then that's negative 2. Okay.